Assalamu alaikum. This is Chayon injamumul. I am presenting traffic light controller using 555 timer IC and CD4017 counter IC to Honorable Chaudhary Akram Hossain sir. Introduction. In modern times, every day the number of vehicles is increasing. We all have seen traffic lights which placed at road intersections, pedestrian crossing and other locations to control flows of traffic. Those traffic lights are used to avoid traffic jams and accidents on roads. The traffic signal has three different colored lights, which indicates three different messages for the drivers: red for stop, yellow for wait, and green for go. In this project, we will make a traffic light controller circuit using 555 timer IC and CD4017 counter IC, which can help us to understand how a traffic light system works. This type of traffic light can be placed at the necessary spot. Project concept and block diagram of traffic light controller. The key components of this project are potentiometer, any 555 timer IC, CD4017 counter IC, and LEDs. The any 555 IC work as an stable multivibrator to produce pulses. The time period of these pulses can be adjusted by the potentiometer. It means the potentiometer is used to change the shifting time of the traffic light. Then the output pulse from the any 555 timer IC goes into the clock input of the CD4017 counter IC. Then the counter IC counts pulse and changes the output line Q logic into high or low. We can obtain traffic signals light by connecting the proper color LED with the counter IC output pins. Here we will use three different color LEDs for each color. Components required: 9-volt battery, 3 kind of resistors, 3 different capacitors, 6 1N4148 diodes, 555 timer IC for pulse generator, 4017 IC as main IC counter, 100K potentiometer that controls the timing of pulse generated by 555 timer. LEDs red, yellow and green as output. Pin diagram of IC4017 counter and 555 timer. Here we can see 4017 pin number 8 GND pin 12 carryout. A carryout completes its one cycle on every 10 clock input cycles. Pin number 13 enable. It is an active low enable pin. Pin number 14 clock input. The IC counts each rising edge applied to this input by 1. Reset. It is an active high reset. Pin number 16 VCC. The VCC pin can be connected to a supply voltage range from 3 volt to 15 volt. Now we can see 555 timer. Pin number 1 ground. This pin should be connected to ground. Pin number 2 trigger. Trigger pin is dragged from the negative input of comparator to output. This pin also has no special function. Pin number 4 reset. This is a flip-flop in the timer chip. Pin number 5 control pin. The control pin is connected from the negative input pin of comparator 1. Threshold pin voltage determines when to reset the flip-flop in the timer. Pin number 7 discharge. This pin is drawn from the open collector of transistor. Pin number 8 power or VCC. It is connected to positive voltage 3 voltage to 15 voltage. Working. This traffic light is made with help of counter IC, which is mainly used for sequential circuit. Sequential circuits are used to count the numbers in the series. The main circuit IC is 4017, which is used to glow the red, yellow and green LED respectively. IC555 timer acts as a pulse generator providing on an input to the 4017 counter IC. Timing of glow of certain lights totally depends upon the 555 timer's pulse, which we can control via the potentiometer. So if we want to change the time of glow, we can do so by varying the potentiometer having the responsibility for the timing. LEDs are not connected directly with 4017 counter. As the lights won't be stable, we have to use the combination of IN4148 diodes and LEDs in order to get the appropriate output. Application of this controller: we can use it as ramp metering, as a timers, in fire station emergency entrance, in medical emergency entrance, at the entrance and exit of cars, at the landing state of a ferry, aboard the ferry. The advantages will be reduced fuel consumption, improved traffic guidance, improved traffic flow, increased safety, and it is low cost. Limitations: excessive delay may be caused, disobedience of signals. The unnecessary delay results in significant fuel waste and higher motor cost. Conclusion of this project: we can increase the efficiency by using microprocessor 8086. We can use this as remote traffic controller. Thank you viewers, and especially Chaudhuri Akram Hossain sir for his kindness and concerns.